can't do, I'll also do question 6 from 5A and question 10 from 5B. 5B1. Is that in the review set, Jenny? The 5B1? Is that one of the review sets? And no, it's not, just in general. Okay, that's separate from that. I'll do it last then. And question 14A in 5A. Okay, so they're all from 5A. Sweet. Okay. Let's start. So the first question: determine the general term of the geometric sequence. Okay. Given its sixth term is 16 over 3, so we know U6 is 16 over 3. And the 10th term, so U10 is 256 over 3. Determine the general term. So the general term, okay, I'm not sure what to do. I'm going to go to my formula booklet. I'm going to do the general term, the nth term, the geometric sequence. And that is given by un u1 and rn minus 1. Okay, so I've set myself up. Now I need to find just the ratio and the first term. Cool. Okay, so the ratio, well, let's think about the ratio between U6 and U10. I know that U6, which is 16 over 3, if I multiply by a ratio, I'll get U7. If I multiply by the ratio again, I'll get U8. And if I multiply by the ratio again, I'll get U9. And if I multiply by one more ratios, I get U10. Now U10 I also know, 2, 5, 6 over 3. So basically I can simplify that down. 16 over 3 multiplied by or 4 times, or by itself 4 times, is 256 over 3. Oh, I can solve this, can't I? Just isolate the or to the power of 4. Now, I'm going to end up dividing by 16 over 3, which is multiplying by 16 over 3. Or you can just use your calculator and divide by 16 over 3. So 3 into 3 goes once. 16 into 256, I know goes. I'm not sure how many times. Or I can just do it on the calculator. What's 16 divided by 256? It's like 16. Thank you. And that's equal to 16. Okay. Or to the power of 4 is 16. What's or? 2. 4th root. Not sure how to get that. Yeah, 4th root. So press 4 and then go to math. Go down to number 5, press enter, and that gives the 4th root, and then press 16, and that gives 2. Okay. And that is the ratio. So I can use that ratio then to work back and perhaps find the first term. Now I could keep dividing by 2 if I wanted, and I could get that first term. Maybe I could use the fact that I know the 6th term is something as well. So the 6th term, U6, I'm just going to come back and use that. Or I could just keep dividing by 2 if you could a few times, but maybe a quick way is U6 is 16 over 3. The first term is unknown, I'll call it U1, but I now know my ratio is 2. So I'm just using the general term. 2 times 6 minus 1 is the 6th term. So 16 over 3, 6 minus 1 is 5. So that's U1 times 2 to the power of 5. 2 to the power of 5 is 32, I think. So if I divide both sides by 32, I get 16 over 3 times 32, and that's the first term. Which, once again, I can do on my calculator, but I think that's 1 and 2. I think it's 1/6, is it? You can use your calculator to find that. Anyone get 1/6? I don't have the answers there, so maybe. Maybe I'll. Okay. I'm not sure. I think it's 1/6 anyway. Maybe you could check the answers. But the general term then, which is what the question asks, is the first term, 1/6, times the ratio, which is 2 to the power of n minus 1. So this is the answer here. We found the ratio to be 2, and we found the first term to be 1/6, and that's question 5. Okay. Question 6 in the same review set. I don't like pencil. Question, insert 6 numbers between, so that all 8 numbers. All right, so once again, 23, and then we have 6 numbers. 1, 2, 3, 4, 5, 6 between, okay. That's what the question says. Insert 6 numbers between 23 and 9, so that all 8 numbers are in a arithmetic. So 23 plus 1 difference is going to give this number, plus 2 difference is going to give that number. So it's going to be 23 plus a difference, 23 plus 2 difference, 23 plus 3 difference, 23. I'm going to stop saying this because you can read it. 23 plus 6 difference. And this is 23 plus 7 differences. If the differences are constant, we don't know what they are, but if they're constant, they will form an arithmetic sequence. So 23, remember this is question 6. 23 plus 7 differences are 9. Okay? And if we find that difference, then we can fill in these numbers, because you're just adding it each time. But I think you're going to, the difference is going to be a negative number because it's going down. Anyway, 7 differences is equal to 9 take away 23. That's going to give a negative 14, I think. That means the difference is negative 2. So that's it, solving algebra. Possibly you could have solved this one trial and error, because you know it's going down, so how much is going down by. So the 21, 19, 17, 15. Yeah. You can use your microphone, you know.
How would you do it for a geometric sequence?
How is it what? Not a geometric?
No, how would you do it for a geometric sequence?
I did say you could turn on the microphone, but I can't hear you. How would you do that? Oh, okay, yeah, so good question. So for a geometric sequence, so let's say it's the exact same thing. We'll just do 4 this time and finish at 9. Okay, so 23 multiplied by something, and that's a ratio. So 23 times or would be the first one. And the next one is going to be times by or again. So that's 23 times or squared. It's going to be 23 times or cubed, 23 times or to the 4, and that'll be 23 times or to the 5 equals 9. And you do it the same way then. Just isolate the or to the 5 and then use the 5th root button on your calculator. That's how you do it. Okay. No problem. All right. The next question, which I stupidly had written them out, then I put them to the bottom of the pile. Question 14a. So this, I presume, is going to be a little bit trickier if it's further than this. Question 14a. The sum of the first n terms in an infinite sequence. Find the nth term. Ooh, that looks difficult. All right. So we have 3n squared plus 5n over 2 is the sum of the first n terms. So let's just park that for a second. What was the first? So the sum of the first n terms of any sequence, of an infinite sequence. Well, that's a formula. Sum of n terms of an infinite sequence. So if I go to my formula, sum of n terms of an infinite sequence. there's two options. It's either arithmetic or geometric. So let's look at the two formulas. So the sum for a arithmetic, that's one of the formulas I can use on the sum of a geometric. Okay, there's my two formulas. I've just taken that down without even thinking about it. Find the nth term. Let's look at this a little bit. I don't have the answer off the top of my head, but let's think about this. This is going to be, if I factor out this n, that's going to be n times 3n plus 5 over 2. So just factor that out. So you got a 3n plus 5 here. So it's the sum of terms. The answer should be 3n plus 1. That's not my answer. Okay, so I'll have that. Oh, let's get 3n plus 1 is my answer. Okay. So in general, oh, this is stumping me a bit. Sum of the first n terms in infinite sequence. Is this making me use sigma notation? So the sum of the first n terms is equal to that. Okay, so what's the first term? This one I might have to wait till tomorrow to do. Can't remember how to do this one. Sum of the first term. 1, 3 plus 5, 8 over 4. Sum of the first two terms. So what I'm doing here, sorry, I'm not explaining what I'm doing. Let me just start that again. If this is the general formula then for the 3n squared plus 5n over 2 for any n terms. So if I find it, what's the sum up to one term? So sum of one term using that formula is subbing in 1. It's 4. This is just what I'm playing around with here. The sum of two terms then is going to be 3 times 2 squared plus 5 times 2 all over 2. That'll be the sum of two terms. This is sum of 2, sum of 1. So that's going to give me 2 squared 4, 12, 12 plus 10, 20. So it's going to be, is that 11? 11, maybe? 22 over 2, okay. Sum of three terms then. So this is still giving me, so I'm kind of using sigma notation, but I don't want to use it because it gets confusing. Okay, so I'm finding what's the total. Remember, this is giving me the sum. This is not the that's not the second term. This is the sum of the first few terms, first three terms I should get from this. So 3 times 3 squared, 9, 27 then times 3. 27 plus 10 is 37. That's not what I wanted. 37 over 2. Okay. Let's just look at these first two terms. So the first term is 4. So what's the second term then if the sum is 11? That's going to be 4 plus something is 11, the sum of the first two terms. So 4 plus 7. And now 4 plus 7, that's the first two terms. That's going to be an addition of 3. I see. This wasn't making sense because I subbed in 2 instead of 3, so now it does work. It makes way more sense. I'll get to that in a second. Okay, so I can see an addition of 3. So my prediction for the next term in the sequence would be 10, wouldn't it? Adding 3, if this is working out. 4 plus 7 plus 10 is 21. So what I want from this is not 37 over 2. I want 21 from this. Let's see, does it work? So that's 27 plus 15 is 42 divided by 2. Yeah, it's 42 over 2, which is 21. Okay, so that is the next term. 10 is the next term. So notice I formed the sequence 4, 7, 10 out of the sums. The sum of the first one terms is 4. The sum of the first 2 terms is 11. So the formula they gave us, I didn't actually have to use any of the formulas from before. They gave us a formula. That's what sigma is, a formula. And the sum of the first 3 terms is 21. And knowing that, I know that, well, 4 is the first term. 4 plus something gave 11, so the something must be 7. And then, so I have found my adding 3. And in my formula then, that'll be 3n, and I can go back to find the constant term, which is plus 1. And that's dumped me a bit. And then prove the sequence is arithmetic. Well, I've done it already because of a constant difference here, and I could say 7 take away 4 is 3, and 10 take away 7 is 3, so there's a constant difference. That's proved as arithmetic. Yeah, that was tricky. They gave you a formula for the sum. They've worked it out already. I didn't have to use a formula. They gave it to me. All right. That was a very tricky question. Okay, and Jenny's question then to finish, and then I'll let you guys do some study for tomorrow. Jenny's question was 5B, what? Question 10. That's way back into the chapter. Scroll. Okay. 5B1, question 10. All right, so that question, make sure I'm on the right one. A sequence is defined by the formula U1 is equal to minus 12, and UN plus 1 is equal to UN plus 7. Okay. Prove that it is an arithmetic sequence. Wow. Okay. So this is a bit similar to the one we just did. As in, they're creating a different formula for it. We got to understand what it means. The first term in the sequence, whatever it is minus 12. And we don't know the next term. But what does this say? This says that the next term in a sequence can be gathered by adding 7 to the previous term. So what this is a fancy way of telling us is the rule, or what I'm adding each time. Any term plus 7 gives the next term. So this term plus 7 gives the next term. Plus 7 minus 12 plus 7 is minus 5. Plus another 7 is positive 2. Okay? So to prove it, the sequence is arithmetic, then you just say, oh, well, then U2 minus U1 would be minus 12, or minus 5 minus 12 is positive 7. Or you could just say, reading this, if you want to not use actual numbers, UN plus 1 minus UN, if I just bring over equals 7. That's already proved. That means any term, take away the previous term, is 7. So it's proved. Now, I'm not going to give you a proof question stuff because we haven't really done any proofs. So, but that has proved it already, just that. Any term, take away the one previous, is 7. So that means it has to be a constant difference if you subtract. Okay, so that's it proved. You can just write that. That would be fine. Or do this and then do it again. So if I know there's a constant difference of 7, part B asks to find the 200th term. So I can find the formula then. Formula is going to be 7n. And if I look back at this, I think minus 19 is the formula, and you can work that out for yourself. UN is that. So that's the 200 term. Sub in 200 into here. 7 times 200 minus 19. That's 1,400 minus 19. And you will get whatever that is. Okay, hopefully that's the right. And is 1,000 a member of this? And that's once again using this. Does 1,000, this is part C, is 1,000 a member of this sequence? 1,000, you set it up so 1,000 is, and then you check, you get a whole number here, so you add 19. This 1,019 is equal to 7n. Divide both sides by 7. Maybe, is that divisible by 7? I'm not sure. No, it's not. You get a decimal, so no. So you get 145.57, so no. Not in the sequence. Good questions from you two. Well done for finding those tricky ones. Yeah, those type of ones where you don't go straight to the formula are difficult. Make sure you try some of those word problems as well. Some depreciation and compound interest questions. They're straight from GCSE. You didn't spend much time on them, but hopefully you're able to deal with them. Okay, and I think there's a few in the practice questions, so maybe you can get to those today. Any other questions you'd like me to do? No. I think it matters just keep practicing these, so you'll see your